Hello, this is a question which is based on selection of an indicator for a particular titration reaction. The question over here says that select the best indicator from the given table for titration of 20 ml 0.02 molar acetic acid with 0.02 molar NaOH. It is given that pKa of acetic acid is 4.74, and these are the list of indicators from where we have to choose. Now understand, this is a titration reaction where indicator is going to indicate the end point of the neutralization. What is the end point of neutralization? It's a point where number of acid is equal to number of moles of base. So acetic acid is 20 ml 0.02 molar. So if we have to find how many milli equivalents were there, so it will be 20 into 0.02, which will be equal to 0.4 milli equivalents. At neutralization, moles milli equivalents of acetic acid should be equal to milli equivalents of NaOH, right? So M1V1 is equal to M2V2, or we can say N1V1 is equal to N2V2, because basicity of the acid and acidity of the base both are 1. So 20 into 0.02 is equal to 0.02 into V. So volume of NaOH that has to be added before we arrive at a neutralization point is 20 ml. So at neutralization, total volume will be 20 ml of acetic acid and 20 ml of NaOH. So final volume at end point will be 40 ml. So this is a balance reaction, and we can see that 1 mole of acetic acid will combine with 1 mole of NaOH to give us 1 mole of sodium acetate as per the stoichiometry of the reaction. Therefore, we can say that moles of sodium acetate is equal to moles of acetic acid added. So that comes out to be 20 into 0.02. So if we have to find the concentration, that comes out to be 0.01. Now we can do it in a shortcut way also, because if volume is doubled, concentration is halved. Therefore 0.02 becomes 0.01. Now when we say sodium acetate, it's a salt of a weak acid and a strong base. So formula for pH over here will be 1/2 pKw plus pKa plus log C. Putting, we get the value as 8.37. So we can see that initially when only acetic acid was there, we were somewhere in the range of 3 to 4 pH. End point achieved at 8.37, and thereafter NaOH was added. If it was added excess, it would be in the range of 13 to 14 pH. Which means we have to see that this endpoint pH 8.37 lies in the working range of which. And in the first one, the bromothiamol. So bromothiamol, the problem over here is initially it will show yellow color, finally it will show blue color, but it will change color well before the neutralization has happened, because neutralization is going to complete at 8.37 pH, whereas bromothiamol blue will change at 7.6 pH. So even though the reaction has not completed, the indicator would have changed the color. Therefore this is wrong. So therefore this pH of this salt should be in the working range, and we can see it is there in the working range of M cresol purple, right? It is midway between them, and therefore 4 has to be the correct answer. So answer for this question is 4.